Hey there, class. Mrs. Matheson here. We're going to cover Unit 9, Notes 4, Multiplying Rational Expressions today. Happy Valentine's Day. Our learning target day today is I can multiply rational expressions. So let's actually just start out with a real-world example here, and we're going to use the idea of multiplying rational expressions with some labels. There are 25 lights around a patio. Each light is 40 watts, and the cost of electricity is 15 cents per kilowatt per hour. Write an expression to calculate the cost of using the light for 3 hours. All right, so we have 25 lights, and each light is 40 watts. So 40 watts per one light. Okay, and the cost of electricity is 15 cents per kilowatt. So the problem gives us watts per hour, so we need to change that into kilowatts. So there's 1 kilowatt per 1,000 watts. We know kilo means 1,000. That's how we can get 1,000. And it is 15 cents per kilowatt, per 1 kilowatt. And we want a cost of the light for 3 hours. Now, when we are doing this, we are looking at our labels, and we want to do some canceling of labels. All right, so we have lights and lights. Remember, it can only cancel from the top and the bottom, like we practiced yesterday. Watts and watts, kilo, kilo. So if we look, we have cents per hour left. All right, so we're going to multiply 25 times 40 times 1 times 15 times 3. And then we're going to, on the bottom, divide it by 1,000. If you go ahead and do that in your calculator, we end up with 45 cents per hour. Okay, so this is just a little real-world example of us practicing canceling labels, which is exactly like what we did yesterday, but we canceled variables. Today, we are going to cancel rational expressions. So our directions are multiply the numerators, multiply the denominators, and simplify the fraction that remains. Go ahead, go back, pause it if you didn't get that. All right, so let's start with some pretty simple. And I'm going to actually show you how to do these problems 2 different ways for you. You pick the way that you like best. So in this first one, we're going to take 5 times 16. 5 times 16, that's going to give us 80. And then we have an a, b cubed, c cubed. And on the bottom, we're going to take our 8 times 15. That gives us 120. We have a squared, b, and c squared. Now this looks very similar to what we did yesterday, and we're just going to simplify. Okay, so simplifying here from top and bottom. 80 over 100. What number goes into both 80 and 100? Ooh, 40. So 40 goes in there too, and there's 3. We have an a on top, so I'm actually going to go right to the answer. An a on top, a squared on bottom. Which one has more? The bottom by 1. The top is b cubed, and the bottom is a b, so the top has b squared. And in our c's, we have a c cubed on top and a c squared on bottom, so we're left with a c on top. And we're going to simplify. This doesn't ask us for those excluded values, but when we get to the back of the note sheet, we'll practice those excluded values again. So there we have that answer. Now let's look at problem 2. I'm going to actually show you another way to do these problems in problem 2. So instead of multiplying the top and the tops and the bottoms, I'm just going to go right to simplifying and then multiply after. So in 2, I see on the top, I have a 5 and a 10 on the bottom. And I know 5 goes into both of those, a 1 and 2 times. All right, so on my top, I have a c cubed and a c. So that gives me c to the 4th, and well, let's just look here. The first one, c cubed and a c to the 4th. C cubed is going to go away, and that's going to turn into a c to the 1st. My d's are going to cancel there. All right, let's look at the next one. We have an f squared on top and an f to the 4th on bottom. So we're going to end up with an f2 on bottom. We have a d cubed on top, no other d's on the bottom. And then we have a c and a c, so those are going to cancel. Now we have to be very careful when we do this with our writing to make sure that we don't miss something. So I'm left in the top with a 1 and a d cubed. And in the bottom, I'm left with a 2, a c, and an f squared. So pay really close attention with this one method is because you can accidentally miss something. So two different ways. One way is multiply the tops and bottoms and then simplify. The second way is to simplify and then multiply the leftovers. You pick either one that works for you. All right, so I want you to pause the video at this time and do 3 and 4. And when you come back, I want you to check your work with mine. So pause the video. Okay, take a look. 3, I went simplified and then I put my answers into my circle. And in 4, I multiplied and then I put my answers at the end. So check yours and see how you did with that. All right, let's go to the back side. Now we're going to multiply rational expressions that has polynomials, so not just monomials like the first 4, but actually polynomials on the back side. So we start again, we factor the polynomial, then we simplify so we cancel anything out. Here's where we have to find excluded values, and then we're going to multiply back together our remaining values or parts to it. So let's go ahead and look at 5. So we're going to factor anything on the top. We have an x minus 5. That's good. X squared, we're good with that. X, ooh, here on the bottom, we can factor this, and I know that'll be x and x. So think about your little x, negative 15, negative 2. Yep, negative 5 and positive 3. Okay, step 2 said to simplify, so we can get rid of our x minus 5s. We have an x squared on top and x on bottom, so those are going to simplify also. So we end up with an x on top and an x plus 3 on the bottom. Now we have to find our excluded values, so we set our denominator equal to 0, and we solve for x. And then we say x cannot be that. Now we don't have anything back that we need to multiply together, so those two are our solutions. Let's see it again with problem 6. Whoop, that moved us the wrong way. There we go. Problem 6. So the top x plus 3 and 5 are factored. Those are good. X, okay, here again, we're doing our plus 12, plus 7, and that gives us 3 and 4. Here we can use our shortcut, x plus 3, x plus 4. We are looking for things that simplify. So we take out our x plus 3s. So on the top, we're left with a 5. On the bottom, remember, we have this x, and we have our x plus 4. Okay, now our next step says to find the excluded values. So here we have 2 parts that we're going to set equal to 0. All right, so this one's already solved, so we just say cannot be. And here we're going to minus our 4s. So then we get negative 4, and we say cannot be. Now this thing here, not our answer yet, we have to multiply this x back in. So we have 5 on the top, and then we get an x squared plus 4x. So we have 1, 2, 3 things for our answer. Let's try that again in problem 7. Problem 7, factor the top and the bottom. All right, so we have y and y. What multiplies to negative 4 and adds to negative 3? That's a positive 4, oops, minus a negative 4 and a positive 1. Okay, so minus 4 plus 1. And on the bottom here, we have just 2 terms. So let's look for a GCF. We can take out y, and so we get y minus 4. So I'm going to cross those out so we don't get confused by those. All right, so simplifying, our y's plus 5s, our y minus 4. So on the top, y plus 1 over y. So excluded values, set the denominator equal to 0. Sweet, this one's easy. Just say cannot, and we don't have anything to multiply through. All right, pause the video here, and I want you guys to do 8, and then come back. And We'll see how your answer compares with mine. All right, take a look. First, I factored the tops and the bottoms. I canceled out anything that was like. I had b ended up with b minus 1 on top, and on the bottom, 4 times b minus 10. I set 4 times b minus 10 to equal to 0, so 4 can't equal 0, so I just cross that out. And we have b minus 10, added 10 to both sides, so we say b can't be 10, and then we have b minus 1 over 4b minus 40. All right, let's go back to some of those funky word problems that we looked at with our first example in this. In the 2004 Summer Olympics in Athens, Greece, Justin Gatlin of the United States won a gold medal for the 100-meter sprint. His winning time was 9.85 seconds. What was his speed, not speed in kilometers per hour? All right, so he went 100 meters in 9.85 seconds. All right, we want his answer in kilometers per hour. So let's first make meters into kilometers. Well, 1 kilometer, we talked about at the beginning of the video, is 1,000 meters. Okay, and then we want to change hours into or seconds into our hours. So there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So let's simplify here. Meters, seconds, minutes. So we're left with a kilometer per hour. So on the top, we're taking 100 times 60 times 60. We don't really need to multiply by this one because it's not going to change anything. And on the bottom, we're taking 9.85 times 1,000. When you do that, we get a decimal, so let's round to 1 decimal place. 21,965.5. All right, and to our last one here. The velocity that a spacecraft must have in order to escape Earth's gravitational pull is called the escape velocity. The escape velocity for a spacecraft leaving the Earth is about 40,320 kilometers per hour. Let's jot that down. 40,320 kilometers per 1 hour. What's its speed in meters per second? All right. So let's change kilometers into meters. We have a kilometers on top, so this time we want a kilometers on bottom. So 1 kilometer is 1,000 meters. Hey, cool, we already got meters. So let's change hours into seconds. We have hour on the bottom, so we're gonna put hour on the top. So 1 hour is 60 minutes. Minutes is on the bottom, so now we're gonna go minutes on top. 1 minute is 60 seconds. Let's see here. Kilometers cancel. Meters is still there. Hour cancels and minute cancels. So now we're left with meters per second. On the top, we're going to take 40,320 and times it by 1,000. And the bottom, 60, 60, so 60 times 60. Go ahead and do that on your calculator and divide them. Don't forget, those should go in parentheses. Those should go in parentheses together before you divide. 11,200 meters per second. All right, make sure you get a worksheet to practice, and also don't forget to take your Schoology quiz.